directed and undirected graphs. So I think the picture really kind of tells the story of what's going on here, but I want you to think of, I'll go into undirected a little bit more, but with directed, obviously there is a location from a starting vertex to an ending vertex, and we can't go back. So this little point right here is that we have our starting vertice, which would be U, and then our ending vertice being V. It's not the same as the other way around, as it would be with the undirected graph, where you think of it as a two-way street. But also in a directed graph, there is something a little extra called acyclic, where there happens to be no loops or cycles in the graph. It's actually really important to identify, because think of Google Maps again, and the Baltimore has a beltway, DC has a beltway. You know, imagine Google Maps telling you to go around the beltway a bunch of different times to get somewhere. It doesn't make sense. So we have to identify if there happens to be any loops or not. Again, acyclic means there's no loops or cycles. And that's called a DAG, which is a directed acyclic graph, which there's a lot of applications for. There's going to be a lot of loops and not. So we'll check about that a little bit more later on. There's also something else that we need to discuss when it comes to directed graphs. I still haven't really gotten into the indirected graphs, is the application of a strongly and a weakly connected directed graph. Now here's the funny part. You think of strong meaning there's a whole bunch of links and they're all linked. It has nothing to do with it. Strongly connected graphs mean that you can pick any node that you see here in this one. Any node. Can you reach any other node in that graph? And it's the answer, because it's basically a loop here. The answer is yes. Whereas in the weakly connected, even though there's a ton of links, if I'm 7 here, I'm pretty much stuck. There's nothing else I can do about it. So that's the difference between a strongly connected and weakly connected. Is not the number of links, but if I can reach every single node within that graph. For an undirected graph, well, again, we've gone over most of it. The order of edges don't matter because it is a two-way street. So, frankly, we'll just leave it at that. But we do worry about if it is connected, if there is a path from every vertex to every other vertex. Not an edge, but just a path. And notice on this one over here, it's unconnected because, gee, I wonder why. That one's just sitting out there by itself. That's definitely a viable option in a lot of applications where you might have something that's offset and away from the rest of the graph or disconnected. That is called an unconnected graph. So there's your differences between your connected and unconnected graphs and our undirected and directed graphs.